In this video, we'll start answering Cambridge Chemistry Paper 4 Theory, which is extended 0620 Paper 4-2. So please make sure that out of it, you learn how to answer questions. And by all means, try to use the space provided, because if you add some more information, it means you are including irrelevant points to your answers. So the main target or the main purpose of my videos will be just to prepare you on how to present answers so that you can get marks as they are located in the question paper. So without wasting time, my dear learners, let us just jump into our main business. Mind you, I said in this video we'll answer question 1 only. So you need to subscribe so that when I publish another video, which will be for question number 2, you'll be able to be notified. So question number 1. Dust particles in the air move around in a random way. What term describes the random movement of dust particles? Do you have a debate in your mind? If your answer is Brownian motion, then you are correct. Identify the particles in the air. Which cause the random movement of dust particles? Look at the marks, my dear learners. You cannot be given 2 marks just by identifying the particles. You need also to give examples. So look at my answer. Pay attention to the way the answers are given. The answer is gas. Molecules such as oxygen and nitrogen. You have 1 mark and another mark. And please use the space provided only. Once you start thinking maybe the space given is not enough, just know that you don't know how to answer questions and you are likely to put a lot of irrelevant points. So go straight to the points. Question A3. Explain why the dust particles move in this way. Which way are we talking about? The random way. We are explaining so that we can get 2 marks. Explain why the dust particles move in this way. How do you get 2 marks? You say because gas molecules collide with dust particles causing the bombarding particles move randomly. Look at the way I am presenting answers, my dear learners. So the key points in my answers, I have stated that what is causing the random movement is because of the collision of the gas molecules and the dust particles. Now, what this collision is causing is the random movement. So be assured of getting a mark because we have stated what is causing the random movement of the dust particles. Learn how to answer questions, and that is the purpose of my videos. B. When a chlorine gas is put into a gas jar, it spreads out to fill the gas jar. When a bromine gas is put in a gas jar, it also spreads out to fill the gas jar. The process takes longer for bromine gas than for chlorine gas. We have an experimental setup, as you can see in the two gas jars. We have the start of the experiment and the end of the experiment. In the start of the experiment, we have the colored gas at the bottom, and we have the colorless gas molecules. You know, my dear learners, that air is colorless because the components of air is actually colorless gases. Now, we have this colored gas which is put at the bottom of the gas jar, and after some time we observe that the color of this colorless gas diffuses to fill the entire space of the gas jar, or to mix up with the colorless particles of gas molecules. What term describes the way that the gas particles spread out? The answer is diffusion. The answer is diffusion, my dear learners. Diffusion is different from Brownian motion. And the way these two terms differs is diffusion deals with the movement of particles from the region of higher concentration to the region of lower concentration, as you just observed my explanation. But when we are talking about Brownian motion deals with the random movement of particles, and it has no direction. The movement of particles in a random way without having any direction or condition. But for diffusion, there is a concentration gradient, which is the condition. So you need to be very, very careful, and you should be able to give the differences between the two important terms. Use data from the periodic table to explain why bromine gas takes longer to fill a gas jar than chlorine gas. Use data from the periodic table to explain why the bromine gas takes longer to fill a gas jar than chlorine gas. Before you present your answers, my dear learners, look at the allocated marks and understand the demand of the question. And the command word of this question is for us to explain. And our explanation should be related to the periodic table. Organize your points very well before you answer. So let us get 2 marks. We are going to say because, bromine gas has a higher relative molecular mass of 160 compared to 71 of chlorine. Then you say heavier particles diffuses at a slower rate. So the question is saying explain why bromine gas. So your explanation should be related to bromine gas. And the bromine gas, in relation to the periodic table, when you find the relative molecular mass of bromine gas, you will find that it will have the relative molecular mass of 160, as compared to chlorine, whose relative molecular mass will be 70. So we expect this molecule to move at a slower rate as compared to chlorine, which has a less mass of 70. Explain why increasing temperature increases the rate at which the gas particles spread out. Explain why increasing temperature increases the rate at which the particles spread out. What will be the effect of increasing temperature? So, how do you get just a mark? Because particles gain more kinetic energy, hence move faster. Interesting. So you will see that the main key of your answer in this B3 is for you to state what happens to the gas particles when temperature is increased on them. The particles will start moving about very fast because they will gain kinetic energy. So the main important point you should state is they gained kinetic energy. And in our part 2, you get 2 marks because you state the magnitude of the gas particles. So the main key is for you to state that 160 is for bromine and 71 is for chlorine. Because you are limiting yourself to the periodic table, you will find data from the periodic table as for you to come up with these magnitudes. And you state that heavier particles diffuse at a lower or slower rate. Thank you so much, my dear learners. This is where we are going to end in this first video. As you wait for question number 2 of this 2017 paper, please subscribe so that you are notified immediately I'll be posting another video. For now, I'll say goodbye. Thank you.